Hello, this is Rajesh and welcome to Softeath Learn. In this lecture, we will talk about programs and programming languages. First of all, let's see what a program. Basically, it is a set of instructions that tell a computer what to do. So, we use program to interact or talk to the computer. So, in order to tell a computer to do something, we should use a program. To write programs, we use programming languages. So, let's talk about programming languages. Programming languages basically are languages are used to write programs. As you know, computers are machine and they do not understand the human languages. So programs are written in a language that a computer can understand, which is a programming language. So to be able to interact with a computer, we should write a program using a language that a computer can understand, which is a programming language. Now let's see what is a machine language. This is the computer native language, so it is the main language of the computer. This language uses 0 and 1s, so the digit 0 and the 1, and this is why it is called the binary language. Binary means two things. So as you can see, we have using two digits, the 0 and the 1. So for example, if we want to add two numbers 2 and 3 and get the result, we would write something like this. This is an instruction written using machine language. It is a group of zeros and ones, as you can see. And this is only one instruction just to get the sum of 2 and 3 and get the answer, which is 5. So as we can see, this is very hard to use. Moreover, machine language is machine dependent, so it is differs among different types of machine. So this code over here might work on a certain machine and it might not work on another machine. So this is what we mean by machine dependent. Now let me tell you, every instruction should be written in machine language before it can be executed. So later on we are going to write program using Java. So the instruction will be written using Java programming language. So all of those instructions must be translated to machine code before we can execute them, and this applies to all the programming languages. Now let's talk about assembly languages. It was developed to make programming easier. First of all, it is also machine dependent, and assembly language keywords were introduced. For example, we have a keyword add for addition and a keyword sub for subtraction and a lot more. So programming was a little bit easier. For example, if you want to add 2 and 3 and get the result, we will write something like this. This is an assembly instruction. We will tell the computer to add the number 2 and the number 3 and to store the result somewhere called result. So this is an instruction written in assembly programming language. So this can not be executed because, as we said, all instructions should be written in machine code before we can execute them. So there is a program called assembler that translates assembly code to machine code. So let's talk about assembler. Suppose that we have this assembly code over here and we said it cannot be executed. So this code is given to assembler and the assembler translates this code to machine code, and now this code over here can be executed. And this is how we can execute assembly code. So whenever we write a program using assembly language, we will translate into machine code using the assembler and then we will execute it. So now let's talk about high level language. So high level language are new generation of programming languages. In high level programming language, we use English words. So this is why high level programming language is easy to learn and easy to use. Also, high level language are machine independent. So our program will run on different machine, and this is very important. And each instruction written in high level programming language is called a statement. So later on, whenever you write an instruction using Java, we will call it a statement. And a program written using high-level programming language is called a source program or a source code. Now let's see this example. If we want to add 2 and 3 and get the result, we do something like this in Java. This is an instruction written using a high-level programming language. So this is a statement. And this is very similar to mathematics. Here you are saying that we want to store inside the result the answer of 2 plus 3. So 2 plus 3 will be calculated. So we get 5 and 5 will be stored in the variable result. In mathematics, we have the concept of the variable, and also in programming, we have the variable. If you don't know what is a variable, no problem. I am going to explain it from scratch. But for now, look at this expression and see how much it is easier than assembly and machine code. Look at this semicolon over here. Basically, every instruction or every statement should end with a semicolon, and you will see this later on. Now, just like before, this is a statement written using a high-level programming language, so it cannot be executed. We should translate it to machine code and then we can execute it. So we can use a program, what's called a compiler or an interpreter, in order to translate a source code to machine code. Here, source code is the program written using the high-level programming language. So, for example, this statement over here is a source code because it is written in our high-level language. So, let's see how we can translate this statement into machine code using the compiler. Basically, compiler translate all the source code into machine code. So, we have a source program or a source code, and we will use a compiler to get an executable code. And an executable is a fixed file that can be executed by our computer. So let's have a look. We have the source code over here, and we use the compiler to generate the machine code. And whenever we generate the machine code, we can execute using executor to see the output or the result. So the compiler convert all the source code or all the programs to machine code, and then we can execute it to see the output. Now let's have a look at the interpreter. It works little bit different from compiler. Interpreter translate each statement into machine code and execute it right away. So it will not translate all the program, it translates each statement at a time. So we have a statement from a program. The interpreter will translate it to machine code and then it will execute, so we will see the output. Now this process will be done on all the statements in our program statement by statement, but the compiler translates all the program into the machine code. So this is the difference between an interpreter and a compiler. So this is it for this video. Thanks for watching, and I will see you on the next one.